Welcome to Creative World. In this video, we will solve Chapter 2 Learning Assessment E2.7. While solving this problem, we will be using Kirchhoff's current law. According to this law, all currents entering to a node is always equal to currents leaving from that node. In the light of this law, we can say that a cumulative current on any node in a circuit is always zero. This is the equation for the Kirchhoff's current law. Summation of all entering currents minus summation of all leaving currents will be equal to 0. Now move towards the problem. Read the scenario. Learning assessment E2.7. Calculate current Ix, I1 and current of dependent source in the given below figure. This is the circuit diagram for the given problem and we have to calculate the values of currents Ix, I1 and current dependent source. Before start solving this problem, if we observe in this circuit, the only information for all elements that is given is in the form of currents. Only the currents of all elements is given and it is also asked to calculate the values of currents. No other information is provided. In order to solve this problem, we can use Kirchhoff's current law, which is purely based on currents. This is the fundamental equation of Kirchhoff's current law. Summation of all entering currents minus summation of all leaving currents will be equal to 0. Before we start solution of this circuit, first we have to identify the number of nodes present in this circuit. If we observe, 3 number of nodes are present in this circuit. This is the reference or ground node. All currents on other nodes will be taken with the reference of this node. Remaining 2 nodes will be used for the solution of this problem. First we will mark these nodes with numbers. This is node 1 and this is node 2. We will start the solution of problem from node 1. At this node 1, first we have to identify all the entering and leaving currents on this node. So at this node only one current is entering, that is 6 milliampere, while other two currents I1 and Ix are leaving from this node. We have identified all incoming and outgoing currents at node 1, so we can place these currents values into the equation of Kirchhoff's current law. Place the entering and leaving currents into the equation. 6 milliampere is entering current while I1 and Ix are leaving currents. Open the brackets and solve the equation. In this equation, two variables are present. We cannot further solve it. Name this equation with equation 1 and move towards the second node. On second node, first we will identify the entering and leaving currents. At this node 2, only one current is entering, that is I1, while 1 milliampere and 1.5 Ix, that is the current of dependent source, are leaving from this node. Place these values into the Kirchhoff's current law. I1 is entering current while 1 milliampere and 1.5 Ix are leaving currents. Rearrange this equation to find the value of I1, that is 1 milliampere plus 1.5 Ix. Again this equation have two variables I1 and Ix. We cannot further solve it, but we can place the value of this I1 into this equation to calculate the value of Ix. If we place the value of I1, that is 1 milliampere plus 1.5 Ix here in this equation, then this equation will have only one variable, that is Ix. So we will be able to calculate the value of Ix, and if we succeed to find the value of Ix, we will place that value of Ix here in this equation and we will be able to calculate the value of I1. So place the value of I1 into this equation 1. Here in this equation, the value of I1 is replaced with 1 milliampere plus 1.5 Ix. And because of minus sign, these two entries are also became negative. Now in this equation only one variable is left, that is Ix. We can calculate its value. Solve the equation to calculate value of Ix, that is 2 milliampere. We have calculated the value of Ix. We can place the value of this Ix into this equation to calculate the value of I1. Place the value of Ix into this equation and solve this equation. Value of I1 will be 4 milliampere. Similarly, we can calculate the current value of this dependent source, that is 1.5 Ix, and we have the value of Ix, so we can calculate its current. Current of dependent source will be 1.5 Ix and the value of Ix is 2 milliampere, so the current of this dependent source will be 3 milliampere. So this was chapter 2 learning assessment 2.7. Thank you. See you again in next video.